Hello, welcome back. In this video, we're going to learn primitive data types in Java. As you can see, we did not start with Eclipse in this video, but we have started with this number sheet. What I have here is the list of 8 primitive data types that are supported by Java and basically their sizes and ranges. We will quickly go through this table before we go and create an example class and then test these out. So there are 8 primitive data types. Some of them are used for some specific purposes. We'll just go through one by one. The first one you see is a char data type. The char data type holds one character information in the simplest terms, right? If you want to save something like A or B or parenthesis or star or anything that is just a single character, you would use the char data type. As you can see, it takes 16 bits, 2 bytes, and we have something like Unicode 0 to Unicode 2 to the power 16 minus 1. Unicodes are basically specific codes to define different characters, not just English, but different languages, and Java utilizes that. But for the purposes of this tutorial, let's just assume or understand that a variable that is defined as a char data type holds just one character. Now, if we move to the next set, there are 4 listed here, and these are all integer data types. When I say integer, if a variable is declared or defined with one of these data types, you can store only integral numbers, no floating points on that. And each of these data types have different ranges. As we go down, the range increases. A byte data type supports only 8 bits of information, which means you just go 2 to the power of 7. So it supports minus 128 to plus 127. And if you need anything more than that, you would use short, which is 16 bits, which means you would go by 2 to the power 15, and you have minus 32768 to 32767. In general programming, you would not use byte and short. If you are very concerned about memory usage on defining a large array where you are storing a lot of numbers, but you are confident that the numbers are going to be in these ranges, you can use these two. But in general programming, we don't use byte and short. Int is very common. It, it is the most commonly used data type if when we store integral numbers, because the range is quite decent to accommodate any normal integral value that you want to capture in the program. It takes 32 bits and the calculation goes the same way, minus 2 to the power 31 to plus 2 to the power 31 minus 1. So that's integer. Long is a really long number. As you can see, this is the range supported by long. We normally don't require long unless you're doing storing some wealth information of some, really wealthy individuals and stuff like that. But normally we don't use long either. We pretty much stick with int. But you can use long if there is a need. So these 4 are the 4 integral data types supported by Java. As we move down, the 2 that we have here are for decimal values. First is float, which has 32 bits of information. Um, there is the IEEE 754 standard for floating point, which is supported by Java, but you can just assume that the difference or understand that the difference between float and double is float holds less precision compared to double. Double lets you store much more precision. I think it's 15 um, numbers after the decimal point, whereas float is only 7. And then we have Boolean. Boolean does not have a range because all it stores is just true or false. I believe it takes about a single bit of storage in memory, but it's not defined in Java anywhere on how much a Boolean data type takes. But all we can store in it is the value of true or false. So these are the 4 data types in Java. Now let's go ahead and create a new Java class and test these out real quick. Let me switch back to Eclipse. We're going to create a new class and let's call it primitives. We will create our main method as well. So we already used the int data type in the other videos. For example, variables had a number that is defined as int, and this is pretty much what the primitive data type int that we just saw. Let's go ahead and create a new byte of value sample byte equals minus 100. So that's pretty good. So we created a byte. Let's create a shard. Sample shard equals 1000. And let's go int sample int equals 10,000 and long sample long equals let's some big number of type int is out of range. This is because in Java a regular number is always considered an int. So what we are saying is store int in long. If we change this to L, now this is fine. If you add a L at the end of the number, you're telling Java that you are saying this is a long number. What gets stored in sample long will not be this number followed by L. What's stored in sample long would be only this. L is just a way of us telling Java that, hey, this number is a long number. Let's go ahead and quickly print that to confirm that theory. If I do a print of sample long, let's go ahead and save. I'm going to right click to run as Java application. You just get the number. So L is not part of the number. L is just a way of us telling Java that this is a long number. Let's do the floating point now. You will see something interesting when we type float. Sample float equals, let's say, 2.5. We get an error. But 2.5 should be within the range of what sample float is, because if I switch back to numbers, you see that floating point takes 32 bits, so 2.5 is a very small number. So why did we get the error? Now if we go quickly back here and check what the error is, it says cannot convert from double to float. What this tells us is for Java, any decimal number is by default a double, not a float. So what we're telling Java here is, hey, take this double number, which has a larger precision, and assign it to a floating point variable where we might actually lose precision, right? So Java is complaining, hey, I cannot assign a double number to a float. Now to overcome this, just like we put a L here, we just have to do a D here and save. Oh, should be capital D. Should be small d. What's going on? Oh, sorry. Terrible, terrible, terrible. So we have to tell it we're going to store the float in the floating variable. Sorry about that. So what we're saying is, hey, we know this number is a float, so assign it to float. If we don't have it, it becomes a double number, and we cannot assign a double to a float without making the number itself a floating point. Sorry about that. Now I can do a double sample double equals 2.5. This is perfectly fine because we're just assigning a double number to a double variable. So that's floating points and double. Now we need to look at car data type. So car sample car equals C. So we just entered a single character and assign it to a variable that is defined as a car variable. We can print this and say sample car is plus sample car, save it and run it. Get sample car is C. So you can save a car data type and then print it just like any other variable. Now the final one we want to look at is Boolean. Boolean sample Boolean equals false, because the only two values that are allowed for a Boolean variable is true or false. or we can just say sample, or we can change the sample boolean to true. We cannot store any other value in this, so if we say sample boolean equals C, we're going to get an error saying cannot convert from car. As you can see, if you put something in a single quote, Java will know it's a car. So it's saying, hey, I cannot convert a car to a boolean. So the data types are basically a way of us telling Java what are we planning to do with a particular variable. When we say sample length is an int, we're telling Java that, hey, we are planning to store an integer value within a particular range into this variable. So these primitive data types are the building blocks of Java. This is what you would use in other classes that we will build later in our tutorial. But just play with different numbers, just like, some of them will stump you, just like I had the problem with the D here. I was actually saying, hey, it's a double assigned to a float, which was again terrible. But play with these assignments, assign different values, and I'm going to add this to the section as well. So you will have this as a reference. So you can look here for the ranges and then try to assign different values to these variables and test them out. It is really important to get a good understanding of these primitive data types because as I said, these are the basic building blocks. So have fun. See you in the next video.